The Foundations of Geometry by David Hilbert. Chapter 1. The 5 Groups of Axioms. Section 6, Group 4, Axioms of Congruence. The axioms of this group define the idea of congruence or displacement. Segments stand in a certain relation to one another, which is described by the word congruent. 4,1. If A and B are 2 points on a straight line A, and if A' is a point upon the same or another straight line A', then upon a given side of A' on the straight line A', we can always find one and only one point B', so that the segment AB, or BA, is congruent to the segment A'B'. We indicate this relation by writing AB is congruent to A'B'. Every segment is congruent to itself. That is, we always have AB is congruent to AB. We can state the above axiom briefly by saying that every segment can be laid off upon a given side of a given point of a given straight line in one and only one way. 4,2. If a segment AB is congruent to a segment A'B', and also to the segment A'B', then the segment A'B' is congruent to the segment A'B'. That is, if AB is congruent to A'B' and AB is congruent to A'B', then A'B' is congruent to A'B'. 4,3. That AB and BC be 2 given segments of a straight line A, which have no points in common aside from the point B. And furthermore, let A'B' and B'C' be 2 segments of the same or of another straight line A', having, likewise, no point other than B' in common. Then, if AB is congruent to A'B' and BC is congruent to B'C', we have AC is congruent to A'C'. Definitions: let alpha be an arbitrary plane, and H and K any 2 distinct half-rays lying in alpha and emanating from the same point O, so as to form a part of 2 different straight lines. We call the system formed by these 2 half-rays H and K an angle, and may represent it by the symbol angle H, K, or angle K, H. From axioms 2, 1 through 5, it follows readily that the half-rays H and K, taken together with the point O, divide the remaining points of the plane into 2 regions having the following property. If A is a point of one region and B is a point of the other, then every broken line joining A and B either passes through O or has a point in common with one of the half-rays H or K. If, however, A' both lie within the same region, then it is always possible to join these 2 points by a broken line which neither passes through O nor has a point in common with either of the half-rays H or K. One of these 2 regions is distinguished from the other in that the segment joining any 2 points of this region lie entirely within the region. The region so characterized is called the interior of the angle HK. To distinguish the other region from this, we call it the exterior of the angle HK. The half-rays H and K are called the sides of the angle, and the point O is called the vertex of the angle. 4,4. Let the angle HK be given in the plane alpha, and let the straight line A' be given in a plane alpha prime. Suppose also, in the plane alpha, a definite side of the straight line A' be assigned. By denoting by H' a half-ray of this straight line A' emanating from a point O' of this line. Then in the plane alpha prime there is one and only one half-ray K', such that the angle HK or KH is congruent to the angle h prime k prime, and at the same time all interior points of the angle h prime k prime lie upon the given side of a prime. We express this relation by means of the notation the angle hk is congruent with the angle h prime k prime. Every angle is congruent to itself. That is, the angle hk is always congruent to the angle hk, or the angle hk is congruent to the angle kh. We say briefly that every angle in a given plane can be laid off upon a given side of a given half ray in one and only one way. 5, if the angle hk is congruent to the angle h prime k prime and to the angle h double prime k double prime, then the angle h prime k prime is congruent to the angle h double prime k double prime. That is to say, if the angle h comma k is congruent to the angle h prime k prime, and the angle h comma k is congruent to the angle h double prime k double prime, then the angle h prime k prime is congruent to the angle h double prime k double prime. Suppose that we have given a triangle ABC. Denote by h and k the two half rays emanating from A and passing respectively through B and C. The angle HK is then said to be the angle including the sides AB and AC, or the one opposite the side BC in the triangle ABC. It contains all of the interior points of the triangle ABC, and this is represented by the symbol angle BAC, or angle A. Group 4, Axiom 6. If in the two triangles ABC and A prime B prime C prime, the congruences AB to A prime B prime, AC congruent to A prime C prime, and the angle BAC is congruent to B prime A prime C prime hold, then the congruences angle ABC congruent to angle A prime B prime C prime, and the angle ACB congruent to the angle A prime C prime B prime also hold. Axioms 4, 1 through 3 contain statements concerning the congruence of segments of a straight line only. They may therefore be called the linear axioms of Group 4. Axioms 4, 4, and 5 contain statements relating to the congruence of angles. Axiom 4, 6 gives the connection between the congruence of segments and the congruence of angles. Axioms 4, 4 through 6 contain statements regarding the elements of plane geometry and may be called the plane axioms of Group 4. The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice: this ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Wrenholt. Programming and illustrations by Jim Wrenholt. 2019. Portrait of David Hilbert by Reida Wrenholt. Thank you for listening.